Lecture problem 2. A billiard ball of mass m moving with a speed v1 equals 3.0 meters per second in the positive x direction strikes an equal ball initially at rest. Ball 1 is observed to move at an angle of 30 degrees above the positive x-axis, and ball 2 is observed to move at an angle of 60 degrees below the positive x-axis. What are the speeds of ball 1 and ball 2 after the collision? First, let's represent this question by means of a diagram. Clearly from the diagram we see that ball 1 is moving along the x-axis with the velocity v1. Ball 2 is initially at rest, v2 is equal to 0. After the collision, ball 1 is moving with the velocity v1 final above the positive x-axis at an angle of 30 degrees, and ball 2 is moving with the velocity v2 final below the positive x-axis at an angle of 60 degrees. Since the net force at the time of the collision is equal to 0, therefore the momentum is conserved. The P initial must equal the P final. The momentum initial comes from two objects, mass 1 times its velocity plus mass 2 times its velocity v2. Remember that mass 1 and mass 2 are equal. After the collision, the two balls do not stick together. Therefore, m1 has its own velocity v1 final and m2 has its velocity v2 final. Since the velocity v1 final and the velocity v2 final are not lined up neither along the x nor along the y, let's break them into components. The x component for v1 final is positive v1 final cosine the angle 30, and the y component is also positive v1 final sine the angle of 30. The x component for v2 final is positive v2 final cosine 60. However, the y component is negative v2 final sine the angle 60. Clearly, the y component of v2 final is pointing towards the negative y. Notice that in my conservation of momentum equation, I have two unknown velocities, v1 final and v2 final, and that's the reason why I had to involve the angles while breaking the vectors into components. As a result, the x component of this conservation of momentum equation is the following. m1 v1 has an x component only, and it is positive m1 v1. m2 v2 is equal to 0 because the ball number 2 is at rest before the collision. That is going to equal m1 v1 final cosine 30 plus m2 v2 final cosine 60. Those two components are clearly shown in the diagram. The y component has 0 m1 v1 component because the v1 is lined up along the x. The m2 v2 is also 0 for a completely different reason. Ball number 2 is at rest. Those equal m1 v1 final sine 30 minus, notice that the y component for the v2 final is negative, therefore m2 v2 final sine the angle 60. Because the mass m1 and the mass m2 are the same, let's cancel them out right here. These are all the same. The x component is going to be simplified, therefore, to be v1 is equal to 3 meters per second equals cosine 30 is equal to square root of 3 over 2. Therefore, this expression becomes v1 final square root of 3 over 2. The cosine of 60 is equal to 1/2. Therefore, this becomes V2 final times 1/2. In a similar way, the y component will be 0 on the left-hand side because V1 is lined up along the x. That is going to equal the V1 final sine 30. Sine 30 is equal to 1/2. Therefore, V1 final times 1/2 minus V2 final sine 60 is equal to square root of 3 over 2. V2 final square root of 3 over 2. Now, using the y equation, which is the simplest of the two equations, we can cancel the half by multiplying both sides of the equation by 2. This half would cancel with this half. As a result, V1 final is going to equal V2 final times square root of 3. Now we can substitute the V1 final in the x component equation, where 3.0 equals, instead of V1 final, we substitute that by V2 final times square root of 3 times the square root of 3 over 2 plus 1/2 V2 final. Simplify this equation further. 3.0 equals square root of 3 times square root of 3, that's 3. Therefore, the first term becomes 3/2 V2 final plus 1/2 V2 final. That means that 3.0 equals 2 times V2 final. Solving for the V2 final, we obtain 1.5 meters per second. Substituting this value of V2 final in the other equation that relates V1 final to V2 final, we obtain V1 final to equal 2.6 meters per second.